Hello students. Today I will be discussing about moments. So first, what is a moment? Whenever we want to find out the nth, that is, yeah, uh, it is nothing but it is the moment is the set of statistical parameters to measure a distribution. It is a set of statistical parameters to measure a distribution. So moment is nothing but it is the set of statistical parameters. So when we are defining a moment of a random variable, it is nothing but it is the expected value of powers or related functions of the random variable. That is, moment of a random variable. Moment of a random variable is expected values of powers or related functions of the random variable. Yes. So, for example, if I consider the first moment, then it is nothing but mean, or it is also called as average. If I consider second moment, it is nothing but variance. Like this, various these are the mean or variance. These are all the statistical parameters. So moment is nothing but it is the set of statistical parameters to measure a distribution of the random variable. So mainly there are two types of moments. So yeah, there are two types of moments. One is moment about the origin and the second one is moment about the mean. So for some calculations we will be taking moments about the origin and for some calculations we will be taking moment about the mean. Yeah. Moment about the origin is one category of moment and next is moment about the mean. Mean value we know x bar, right? So moment about the origin is one and the second one is moment about the mean. So first we will take and moment about the origin. is represented by mn. Moment about the mean is represented by mu n. Yes, and this mu n is also called as central moment. Central moment. So this is about the moment. There are two types of moments, moment about the origin and moment about the mean. Yeah. Just I want to take up some questions here. Define moment. What is the definition of the moment? And then one more question. What are the two types of moments? Right? Take 1 minute of time and think. Just now we have discussed the definition for the moment and what are the two different types of moment. Yes, moment is nothing but set of statistical parameters to measure the distribution. Like this, we can define the moment. And also, it can also be the expectation. It can also be defined as the expectation. Okay. Uh, and two types of moment are moment about the origin and moment about the mean value. So, first we will discuss uh, in this session moment about the origin. Yes. So when we consider a function g of x, which is a real function, so let us consider a function g of x, and this is a real function of a random variable. Of a random variable x, such that g of x is equal to x raised to n. It's like, yeah, g of x is equal to x raised to n, and the n values will be all the numbers 0 to yeah, all the numbers, real numbers you can take. Then for this, moment about the origin is defined by the following equation. Moment about the origin is defined as Mn is equal to, it is nothing but moment. Here it is nothing but, as I have told, it is nothing but expectation of nth power of x. So same thing we are taking here, x raised to n. So I'll apply the formula for the expectation. This I'm applying for the continuous random variable. So integration of minus infinity to infinity x raised to n f of x into dx. So this is for the continuous case. The same way we can define the moment about the origin for the discrete case. It is also expectation of x raised to n, but I will apply the formula for the discrete random variable. Summation I is equal to 1 to n xi raised to n probability of xi. And this is for the discrete case. So here we have defined the moment about the origin for two cases. That is, for the continuous case, it is moment Mn is equal to expectation of x raised to n, that is minus infinity to infinity, xn f of x into dx. This is for the continuous case. Mn is equal to e of x raised to n, summation I is equal to 1 to n xi raised to n probability of xi. This is for the discrete case. So in this way, we are defining the moment about the origin. For this moment about the origin, we can take different cases. In the same formula, if I put n is equal to 0, that is called as zeroth moment. N is equal to 0. If I substitute in the formula, I'll be getting 0th moment. So in this same formula, just you mn, I'll be taking it as n is equal to 0. So e of x raised to n, it will become e of x raised to 0. So just apply the formula minus infinity to infinity x raised to 0 f of x into dx. So this will be what? Minus infinity to infinity. X raised to 0 will be 1. So minus infinity to infinity f of x into dx. This will be, that is, the density function extending from minus infinity to infinity. The complete density function will be equal to 1. That's why this is the important thing we have derived now, that is m0 is equal to 1. Meanwhile, moment about the origin. In that, when n is equal to 0, it is equal to 1. In the same manner, if I put n is equal to 1, I'm going to get the first moment. N is equal to 1 means we are going to get the first moment. So M1 is equal to expectation of x raised to 1. That is, I can write the formula for this: minus infinity to infinity x into f of x into dx. This is nothing but, it is the expectation of x, right? So I can write it as mean value. Hence, we will be writing m1 is nothing but, it is giving me the expectation of x. That is, it is giving me mean value. So this is, yeah, we came to one of the, m1 is nothing but it is the That is, first moment is nothing but it is the mean value, right? Yeah. One more, last one, that is in the same formula, when I put n is equal to 2, I'm going to get the second moment. That too, second moment about the origin. I'm going to get the second moment about the origin. So just I'll put here M2 is equal to expectation of x square. Wherever n is there, just I've substituted n is equal to 2. Here nothing but minus infinity to infinity x square fx of x into dx. Hence, I can write this as, this is nothing but x bar square. That is mean square value. Mean square value. This is giving me the mean square value. So we have seen total, like when n is equal to 0, the value is 1. When n is equal to 1, the value is x bar, that is the mean value. And when n is equal to 2, it is the mean square value. Yes. So we have seen the definition of the moment, and in that moment definition, we have put n is equal to 0, n is equal to 1, n is equal to 2. Right. That's it for this video. In the next video, we will see about the moment about the mean value. In the same way, how we have seen for the moment about the origin, in the same way, we will see the moment about the mean value. Thank you, students.